three-phase induction motor. Electric machine. It converts electrical energy into mechanical energy. So an electric motor uses electrical energy to produce mechanical energy through the interaction of magnetic field and current carrying conductor. Basic application of electric motors are industrial fans, blowers, pumps, machine tool, household appliances, power tools, disk drives, and so on. How these motors are classified? Motors are classified first based on their type of the source. It may be AC motor, which may be single phase or three phase, or motor may require DC supply, or motor may require AC or DC both. Secondly, they are classified on structural feature. Motor may be open, or it may be enclosed, or it may be partly enclosed, that is called semi-enclosed, or it may be ventilated. Third, motors are classified according to speed. Motor may be constant speed, or it may be variable speed, or it may be adjustable speed. Motors are also classified based on types of motion, that is based on principle of operation, whether motor runs at the synchronous speed or it is asynchronous motor. Asynchronous motors are induction motor and commutator motor. Now in this classification, induction motors are mostly used. Now why induction motors are preferred in industry? Due to simple construction, its cost is very low, it is reliable, it gives high efficiency, and absence of brushes which are required in DC motor. As brushes are not used, so maintenance is very low. It has the simple starting arrangement, and due to modern power electronics, the speed control of motor becomes easy. How this induction motor works? That is the principle of operation of induction motor. When three-phase supply is given to stator, it produces the rotating magnetic field. The rotor is stationary, so it cuts revolving field, and due to electromagnetic induction, an EMF is induced in rotor conductor as per the Faraday's law of electromagnetic induction. As rotor conductor is short-circuited, current flows through it, and it becomes current carrying conductor placed in magnetic field, and motor starts rotating. Now when motor starts rotating, stator produces the magnetic field which rotates at the synchronous speed. Rotor always rotates at the speed which is less than the synchronous speed. The difference between this synchronous speed and rotor speed is nothing but the slip. This is the expression for the slip, where ns is the synchronous speed and n is the rotor's actual speed, and the ns minus n is called as the slip speed. Now principal components, there are the two basic components. This shows the construction of motor, various parts of the motor. So you can see here there are two main components. One is the stator and second is the rotor. Stator and rotor. Rotor is separated from the stator by very small air gap in the range of 0.4 mm to 4 mm, which depends on power of motor. So stator consists of winding to which supply is given. When supply is given, it produces the poles. Now this number of poles, it may vary in motor types, but they are always in pairs, that is 2, 4, 6. It depends on the speed desired. Rotor. Induction motors can be classified as per the rotor construction, that is squirrel cage induction motor or slip ring induction motor. Rotor may be of solid core rotor also. Squirrel cage rotor. This is the most common type of the rotor. It consists of solid bars which is either of copper or aluminum. These solid strips or bars are shorted at the end, which is called end rings. Okay. So you can see here, this is the end ring. The rotor bars are not straight, okay, like this, but they are some skewed, which reduces noise and harmonics. Three-phase squirrel cage motor is rigid and reliable, and so it is most common type of the motor in industry. These squirrel cage motors are used in lathe, pumps, blower, fans, compressor, textile mills, and so on. This is the second type of the rotor, which is called wound rotor, or it is called a slip ring induction motor. This is specially constructed to accomplish a speed control. Rotor is constructed with the windings. The terminals are brought out and they are connected to these three slip rings. These terminals are connected to resistance in series through which speed can be controlled. The torque performance of the motor can be controlled by using this variable resistor. So this motor is particularly suitable for high starting torque, smooth speed control, and so main applications are like rolling mills, lift, cranes, and etc. These motors are most common in the range of 300 HP and above. Rotor, it may be solid core rotor also. So here rotor is made from solid mild steel, and so current induced in this rotor, it causes the rotation. Here, as the conductors are absent, so this motor gives very low noise.